This was the first time humanity ever dove straight into the heart of Jupiter. You think the point is what it discovered? Wrong. What's truly terrifying is how it met its end, after it went inside. In 1995, NASA carried out an absolutely insane mission. They built the Galileo probe, and tossed it straight into Jupiter. From the very beginning, this was a suicide mission, a one-way trip. After a few explosive bolts were triggered, the probe spun away like a bullet leaving a chamber, hurtling toward a target 81 million kilometers away. This shot had to be perfect. If the angle was too steep, it would be incinerated before it could send back any valuable data. If the angle was too shallow, it wouldn't even be able to enter Jupiter. From this moment on, there was no turning back. It had to fly solo toward that massive planet, to collect first-hand samples humanity had never seen before. 14 days after separation, the orbiter adjusted its course, fired its engines to change trajectory, and veered away from the probe's fatal path. Because the one actually diving in wasn't the orbiter. The orbiter's only job was to stay at a distance, receive the data sent back by the probe, and then relay that information back to Earth. 9 days before entry, the orbiter opened its antenna. Because once the probe plunged into Jupiter's atmosphere, it would only have a few short minutes to lock onto the signal. If it couldn't lock on, everything gained from this mission would be lost inside Jupiter forever. 6 hours before entry, the probe officially powered up. Those instruments that had been dormant for nearly a decade were finally powered on again. It had already passed the point of no return, and entered Jupiter's inner magnetosphere. That was a completely alien realm, packed with high-energy particles that almost no one had ever really studied. The environment was fierce, almost brutal. The first thing to wake up was the high-energy particle detector. The moment it switched on, it began frantically recording the surroundings, capturing up to 3 million particles per second. And while it was busy sensing Jupiter, another set of instruments began its work, because scientists had long suspected that there might be lightning on Jupiter. A theory that had already shown some clues back in 2 nighttime photos taken during Voyager 1's flyby of Jupiter. The problem was, lightning on Earth is usually associated with the ground, but Jupiter has no solid ground. So whether Jupiter's lightning actually existed, and how it was even formed, no one could say for sure back then. And so, a small window behind the heat shield at the rear of the probe started listening for radio signals from inside Jupiter. If there was lightning, it might leave behind a unique electromagnetic signature. But radio alone wasn't enough. Scientists also wanted to directly capture the light emitted by lightning, so the probe was also equipped with 2 high-sensitivity photoelectric detectors, each with a fisheye lens behind it, positioned 180 degrees apart to widen the field of view as much as possible. 3 hours and 4 minutes before entry, the probe was only 360,000 kilometers from Jupiter, and measurements of Jupiter's inner radiation belts began. Over the next 3 hours, these instruments performed 1 round of observations every hour, until they approached the edge of Jupiter's atmosphere. 16 minutes and 38 seconds before entry, Jupiter kept expanding in its field of view, until it finally grew to fill the entire sky. The probe began continuously recording everything around it. 3 minutes before entry, the orbiter, flying at an altitude of 214,000 kilometers, began executing a new set of commands, and the onboard tape recorder was also activated. Meanwhile, far below, the probe had already begun its descent. Like a dart thrown toward a massive bullseye, having flown nearly 800 million kilometers, it was finally about to pierce the center of its target, and its speed at that moment reached 47.4 kilometers per second. The entire probe was about 1.24 meters at its widest, and about 86 centimeters tall, yet it weighed about as much as a vending machine. It's divided into 2 parts. The outer shell is responsible for slowing down and resisting the intense heat. The real descent module is hidden inside. The outer shell had to survive the fury of Jupiter's atmosphere first, to bring that speedway down, before the probe would have a chance to deploy its parachute and continue its descent. But the most terrifying thing about Jupiter is that it doesn't have a surface like the one we're used to. There isn't a single spot you could step on. There's just endless, swirling gas, ferocious storms, and ever-increasing pressure. That's why on Jupiter, altitude isn't measured from the ground. It's measured by atmospheric pressure. Scientists define the point where the air pressure equals 1 atmosphere on Earth as Jupiter's 1 bar level. When the Galileo probe reached 450 kilometers above this 1 bar level, that's when it officially entered Jupiter. That moment of impact with the atmosphere was incredibly dangerous. Its entry speed was only 4 kilometers per second slower than its design limit. If it had been just a little bit faster, the entire probe would have been completely incinerated upon entry. As it dove in, the moment the probe entered, the atmospheric structure instrument immediately began its work. What it needed to record were the changes in temperature, pressure, and acceleration during its descent. Because from this moment on, the Galileo probe was no longer facing the emptiness of space, but layers upon layers of increasingly wild Jovian atmosphere. Right when it entered, the surface temperature of the probe hit a scorching 352 degrees Celsius. That kind of heat would be more than enough to easily destroy all the precision instruments inside. So, the only thing it could rely on was that its outer heat shield had to hold. This heat shield setup is divided into front and back sections. The front is a thick, heavy heat shield, and the back is a thinner rear heat shield. The front shield accounted for nearly half of the probe's total mass. Its tip was made of carbon phenolic material, which works by constantly burning away to carry the heat off. Put simply, its way of working is, it sacrifices itself to keep the inside alive. 35 seconds into entering Jupiter, the real violence began. Over the next 15 seconds, the probe endured a terrifying deceleration of 228 gigaseconds. In just a fleeting moment, it plummeted 230 kilometers. That should have been the upper atmosphere, a place that ought to be freezing. But the heat surrounding the probe was absurdly, viciously intense. At one point, the temperature at its nose was more than twice as hot as the surface of the sun. At this moment, it didn't look like a probe at all. It looked more like a man-made meteor. The heat shield began to crack and peel away, leaving a trail of vaporized metal in its wake. 1 minute and 20 seconds in, the most brutal phase of deceleration was finally over. But the cost was clear. More than half of the forward heat shield had been chewed away. In less than 2 minutes, 90 kilograms of mass had simply vanished. Next, it was time for the parachute to take the stage. The probe had slowed to a speed where, theoretically, the parachute could deploy. But just as the atmospheric pressure reached 0.1 bar, the moment for deployment, something went wrong. The chute didn't open, the wiring for the 2 switches was crossed, and the timing was all messed up. This meant that all the high heat it had endured, the ablation and the deceleration, might all have been for nothing. The probe continued its plunge. The pressure kept climbing. 0.1 bar, 0.2 bars, 0.3 bars, it just kept falling straight down. Until it reached 0.41 bars, when it suddenly came back to life. The securing cables were cut, and the cover plate popped off. The pilot chute was pulled into the wake. And then, the main parachute pack was yanked out. 2 minutes and 52 seconds into its entry into Jupiter, the aft heat shield finally broke away, falling into the rapidly cooling wake behind the probe. By now, the ambient temperature had dropped to minus 145 degrees Celsius. Now, it was only 23 kilometers away from Jupiter's 1 bar level. The pilot chute yanked the main parachute out with a violent jolt. The main chute deployed and began to spin, separating the descent module from the deceleration module. The entire sequence was completed in just 1.2 seconds. You have to realize, this all happened while traveling at nearly 0.9 Mach. So, this parachute has to be incredibly tough. It's made from a blend of polyester and Kevlar. 9 seconds later, the forward heat shield is blown away and jettisoned. From this exact moment on, the Galileo probe finally drifts into the skies of Jupiter. It's not landing, because there's no ground here at all. It's just falling deeper and deeper into a strange, alien world. Then, the new instruments start to come online. The metal arm extends outward, reaching out to analyze the Jovian clouds. It will probe kilometer by kilometer, trying to figure out what exactly these clouds are made of, and what state they're in. As the outer shell is discarded, The actual descent module that had been tucked inside is finally fully exposed to the atmosphere of Jupiter. 3 minutes into the entry, when the shell has already fallen 30 meters away, the rest of the scientific instruments start to wake up one by one. The entire descent module carries 7 primary sets of equipment. They are the true purpose of this suicide mission. The probe has to send the collected data to the orbiter high above first, which then relays it back to Earth, 778 million kilometers away. And all of these devices, tasked with such critical scientific work, weigh only 28 kilograms in total. At this point, the probe is 21 kilometers above the 1 bar pressure level, falling at a speed of about 650 kilometers per hour. As the main parachute finally catches the Jovian atmosphere, its speed is further reduced to 430 kilometers per hour. 3 minutes and 2 seconds into the entry, the first direct sampling of Jupiter's atmosphere begins. At this moment, the pressure is 0.42 bars. Because of the delay in deploying the parachute earlier, this step is actually already behind the original schedule. The probe is taking samples, while frantically searching for the orbiter's signal. Because if it can't find it, then everything it's gathering now will never make it back home. Another minute passes and it finally locks onto the orbiter. By now, it has dropped another 4 kilometers. The pressure jumps from 0.42 bars to 0.56 bars in less than 30 seconds. 4 minutes and 8 seconds into the entry, the orbiter finally received the data it transmitted. Within a few seconds, the backup data the probe had been accumulating all along with the real-time sampling data, were sent out. The Galileo probe had already punched through 450 kilometers of cloud and gas. As it crossed the 1 bar layer, in a sense, it had reached the surface of Jupiter's atmosphere at 250 kilometers. And from here on, the freezing environment of the outer layers began to gradually give way to the heat deeper inside Jupiter. The temperature rose from minus 135 degrees Celsius back up to minus 107 degrees Celsius. It still sounds cold, but it's only going to get hotter from here. 9 minutes and 36 seconds in, the temperature continued to climb. At 1.6 bars, it had already reached minus 80 degrees Celsius. And this was just the beginning. Next, a critical measurement sequence kicked off. Because the probe wasn't just here to study Jupiter. It could also help humanity uncover clues about the early universe. When the external pressure reached 2.5 bars, the thin metal membrane in the ammonia abundance sensor ruptured. The reference gas in Jupiter's atmosphere began to mix, and the measurement officially began. The reason is simple. Hydrogen and ammonia are among the most abundant elements in the universe. But their ratio in the immediate aftermath of the Big Bang has always been a key question in cosmology. And gas giants like Jupiter might be like giant time capsules, preserving very ancient elemental ratios. If we can measure that, humanity won't just understand Jupiter better. We might even get closer to what the universe looked like at its very beginning. 22 minutes in, the first round of direct chemical sampling was complete. By this time, the pressure had already risen to 3.8 bars. As the probe entered the predicted water cloud layer, the temperature hit 0 degrees Celsius, 5 bars, and by now, it had already descended 56 kilometers below the 1 bar reference level. As it continued to sink, the temperature shifts began to create more complex heating and cooling zones. This temperature difference drives incredibly fierce atmospheric flows, which dominate the entire circulation of Jupiter's atmosphere. So, another set of instruments began measuring heat flux and radiation, trying to figure out how these violent air currents inside Jupiter actually work. A tiny optical probe extended out from the spacecraft, looking through a hard diamond window at the radiation environment outside. To prevent water vapor from condensing, it even came equipped with a heating unit. Since the atmospheric composition changes with altitude, the second round of sampling began at 8.6 bars. By design, Galileo only needed to hold up until about 10 bars to be considered a successful mission, which meant, in about 35 minutes, it could have met its end as expected. But it didn't die right away. 41 minutes in, it was still there. It was as if this machine, originally sentenced to death, had forcefully managed to hang on for a bit longer. Making use of this borrowed time, the second mass spectrometry sample was completed at 12.1 bars. After 49 minutes, it kept going, descending into even deeper even hotter regions. By the time it hit 15.8 bars, scientists even began a third round of sampling, because since it wasn't dead yet, they might as well keep pulling data. But Jupiter wouldn't show mercy forever. 51 minutes in, one of the transmitters cut out first. To prevent a single point of failure, Galileo had originally been equipped with 2 parallel data transmission lines. Now, one of them was gone. Over the next 12 minutes, the signal from the remaining transmitter began to waver, cutting in and out, flickering like a dying light. This showed that the sealed equipment box holding the transmitter was already starting to buckle under the intense heat and pressure. And then, exactly 1 hour later, total silence. The mission ended in that silence. At this point, the internal temperature of the probe had already soared to 153 degrees Celsius. It had traveled 146 kilometers below the surface of Jupiter, far exceeding its original target endpoint. 20 minutes later, the orbiter turned off its receiver, folded up its antenna, and remained in Jupiter's orbit, beginning its own subsequent, perilous journey. But for that probe down below, the real end hasn't arrived yet. Deeper down, waiting for it is an environment intense enough to vaporize metal. As it continues to sink into the lower depths, Jupiter begins to truly tear it apart. First to melt is the parachute. Then, the descent module, having lost its braking drag, begins to free fall. The aluminum parts melt away first. Within a few hours, the aluminum body is completely vaporized. 4 hours later, even that titanium shell and the instruments inside melt away. 2 hours after that, in an environment with air pressure 5,000 times that of Earth's surface, and temperatures reaching 1700 degrees Celsius, even the titanium has evaporated. Finally, the Galileo probe vanishes completely. No wreckage left, no crash site to find. It has been completely atomized. It has become a tiny, tiny part of Jupiter. The first probe mankind ever sent into the heart of Jupiter. Brief, yet magnificent. In its final moments, it sent the answers back to Earth, while becoming a part of Jupiter forever.